Now let's do some numerical on center of mass, right? This is a question on center of mass. It says a block of mass m is placed on the top of the bigger block of mass 10m as shown in the figure. All the surfaces are frictionless. The system is released from rest. Find the distance moved by the bigger block at the instant the smaller block reaches the ground. This is the figure given to you. This is a bigger block. I'll call it wedge. And this is a smaller block, small m, that is the mass is capital M. Here the mass is 10m. This is a bigger block, smaller block, right? This dimension is given to you, is kept on a frictionless floor. Let me draw the floor also. Is kept on a frictionless floor. Is kept on this floor, all right? Now, if this mass comes at the bottom, when the system is released, this mass will come at the bottom. Can you tell me in which direction this should move? We have done this question. We have found the acceleration of the wedge. We did it in forces. So if this block is moving in this direction, from the free body diagram, this will be exerting some normal reaction and we should have a component in this direction. So this block should move towards the right. This block should move towards the right. Right. Okay, anyway, if you take block moving towards left, then you will get the answer in negative, and then you'll come to know that you assume the wrong direction. So we have to solve the center of mass. It can be solved using forces also when this angle is known, but we have to solve it by center of mass. It said, the question asks, when this block comes at the bottom, by what distance this bigger block has moved? When this block comes at the bottom, by what distance this bigger block is moving on the floor. All right. See, in this case, if I consider bigger block and a smaller block as system, I'll call it system of bigger and a smaller block, and on this system there is no force acting in, I can say, x direction. There is no force, no external force, acts in x direction. The normal reaction which the body exert on each other is an internal force. So there is no external force acting in x direction. So I can say that ACM x is 0 or VCM x is constant. And initially the smaller block and bigger block both were at rest. So when both were at rest, I can say initially VCM x 0, or I can say XCM is constant, or I can say XCM is constant. Okay, so XCM is remaining constant. Even if they are moving, XCM will remain constant. There is no force, there is no external force acting in x direction. ACMX is 0, so VCMX is constant, and initially VCMX was 0, so it will always remain 0. It means XCM will remain constant. XCM is going to remain constant. We will make use of this information in solving this problem, right? First of all, let's try to take a reference for measuring all the distance in x direction. Let's take a reference for measuring the position of this mass, and XCM also. Let's take a reference. Let's take a reference like, say, this is the reference, or I should write. So this green line is a reference for measuring x positions, x coordinates, right? For measuring x coordinate, this is the reference. All right. So now x is, now let me find XCM. Let me find now XCM. I'll rub all this. I'll find XCM initially, and I'll find XCM when this block comes at the bottom, and then I'll equate them, right? So what is XCM? XCM is going to be m into, suppose this body is lying at a distance of, suppose this body lie at a distance of, say the distance is x1, and the distance of wedge means distance of center of mass of the wedge. Distance of wedge, distance of any rigid body from this reference is distance of the center of mass of the wedge. So that will be distance of wedge means distance of the center of mass of the wedge. So that will come as, say here is the center of mass located. Let's suppose center of mass of the wedge is located at this position. So this is x2. So m into x1 and 10m into x2 upon 11m, right? Now when the system is released, so this is the position of center of mass when at t equal to 0, you can say. Now if suppose the small mass is, if the system is released, this small mass will move, this wedge will move in towards right, this small mass is going to move towards left. So in that process, finally when this mass comes to the bottom, the wedge would have moved, wedge means bigger mass, the wedge would have moved by a distance of say d. Suppose the wedge has moved by a distance of say d. I'll show the wedge by green line now. Suppose the wedge is say, let me draw it. Suppose the wedge moves by a distance of say d. The mass comes over here, and this wedge moves by a distance of d from its initial position. This is your d. So axiom, so the center of mass of the wedge will also move by a distance of d, right? Now your axiom is what? Now your axiom is, now this block has come, I'm treating this block as point mass. This block has come at a distance of d from the reference, and the wedge has gone away by a distance of d. So it is x2. Sorry, this is m into d. Don't get confused. It's not m. This is m into d, right? M into d, and this is then 11m, right? This is a new position, but the axiom has to be equal. Since axiom do not change, so I'll equate them. What will I get? I think this x1 is given to me. X1 is 2.2, so I have to replace it by 2.2. This x1 is at a distance of 2.2. So I'll equate them. What do I get? I get 2.2 into m and 10m x2, and I get md plus 10m x2, 10md, or d is 0.2 meter. I'll get d as 0.2 meter. See, if you see, I took the help of free body diagram and decided that this wedge is moving towards right. If some of you text wedge to be moving towards left, then you will get your answer negative. That also is correct. You can take your wedge, because see, when I am doing question by center of mass, I need not apply my knowledge of free body diagram, right? I must do it by center of mass only. So if some of you text wedge to be moving towards left, then you will get your answer negative, and then you can conclude that the direction in which you have taken the wedge to be moving is incorrect, and it is basically towards right. Anyway, I told you center of mass is average. So if you want to keep your average same, if x position of one mass is falling, then x position of the other mass must increase. If you have two subjects, physics and chemistry, and your average is 70%, in next exam, if you want to keep your average same and you know that your marks in physics is falling, then your marks in chemistry must increase so as to keep the average same. So this is simple knowledge of average. If x position of one of the mass is falling, then x position of the one of the body must increase so that the average x position remains same. That's a common sense which you can apply. So this is a question. So this is how we will do the question on center of mass. Center of mass makes your problem, makes your solution very easy. It would have taken a lot of time if we could have solved this problem using free body diagram. Okay, I'll go for the next question. So this is my question. A projectile is fired at a speed of 100 meter per second at an angle of 37 degree above the horizontal. A projectile is fired at a speed of 100 meter per second. This is 100 meter per second. 100 meter per second at an angle of 37 degree above the horizontal. A projectile is fired at a speed of 100 meter per second at an angle of 37 degree above the horizontal. At the highest point, the projectile breaks into two parts in the ratio of 1:3. The smaller coming to rest, find the distance from the launching point to the point where a heavier piece lands. See this picture. We have a projectile which is fired at 100 meter per second at the velocity of 100 meter per second, and the angle it makes with the horizontal is 37 degree. At the highest point, it breaks into two parts. One will be, say, m/4, and the other is 3m/4. It's 1:3, so it has to break into m/4 and 3m/4. This was m, right? So it broke into two parts, m/4 and 3m/4. So the smaller piece comes to rest, so it will undergo a free fall. It comes to rest, so it will start falling vertically downward, and we have to find where this heavier piece is landing. This is the trajectory of heavier piece. So we have to find this distance of this point from this point. This is a launching point. This is the launching point. So we have to find distance of this point from the launching point. So I can do this problem using linear momentum also, conservation of linear momentum, but here I have to do it by using center of mass. See, here the projectile went till here and it breaks off, right? It breaks into two masses. See, while it breaks spontaneously, basically. Nobody hits it. It breaks spontaneously. So no external force is acting except mg. The only force acting is mg. That is, if I write and if I say the center of mass is these two mass, initially see you had only one particle. So for a single particle, center of mass lies on that particle itself. So I can say this is your equation of the motion of center of mass. This is the equation of the motion of center of mass if I take z as this direction, right? So this is the equation of, also I can say y is two-dimensional motion, so I need not go into z. I'll just put minus j. Okay, so this is xy. So this is the equation of motion of the center of mass. Initially it was one body, so for a single body, center of mass lies on that body itself. So when it breaks, no external force is generated. It means what? It means the trajectory which center of mass is following, it should not change. Whatever trajectory is predicted by this free body, this equation, the trajectory which is according to this equation is this trajectory, right? So center of mass should not deviate from this trajectory. Why? Because no external force, the external force earlier also was mg, now also it is mg. So why center of mass should change the trajectory? Center of mass should not change the trajectory. Center of mass was moving along this trajectory, it should continue to move along this trajectory, because when it breaks off, it doesn't generate any kind of external force. Getting your point or not? Center of mass should not change its trajectory, because it can change trajectory only when some new kind of external force starts acting. The external force acting is gravitational force mg only. It was earlier also, it is now also the same force. So center of mass should continue with its own trajectory, and center of mass is going to fall over here. Now, if you want the center of mass to follow this trajectory, this m/4 is following this trajectory. At any point, suppose this is center of mass, this will be your m/4. So your 3m/4 must be on right side. Only then center of mass can be here. Center of mass is the average position of these two, m/4 and 3m/4. So if center of mass is this, m/4 is on this side, left side of center of mass, then 3m/4 must be on the right side of center of mass. If one of your subject, the score is less than average, then the other subject must be having the marks more than your average. So x position of m/4 is less than x position of center of mass. The next position of 3m/4 must be higher than x position of the center of mass. So you can understand why 3m/4 takes this trajectory using center of mass. Why 3m/4 is taking this trajectory. m/4 takes this trajectory. So m/4 is going to be here. Center of mass is going to be here. 3m/4 is going to be here. So what is this distance? This distance is going to be, say I call it x1. x1 is the horizontal velocity u cos 37 into time of ascent, means time its projectile takes to reach the highest position, that is u sin 37 upon g. U is sine 37 is very important angle. See, its sine and cos is very simple. Sine 37 is 3/5 and cos 37 is 4/5. So it's 100 into 4/5 is 100 into 3/5 and 1/10. So 5, 5, 25, 4 times. This is 10. So this comes to be 16 and 3, 48, 480 meter. This is 480 meter, right? Similarly, this is going to be the range of projectiles. This should be 480 into 2, 960 meter. And we have to find this. Let's say this is x2. So center of mass, that is 960, should be equal to m/4 into 480, 3m/4 into x2, and then upon m. So this will give you, this is 960 the position center of mass, position of first particle, position of second particle, m/4 is the mass, 3m/4 is the mass, heavier mass, upon total mass m. So that will give me what? 120 plus 3/4 x2. 3/4 x2 comes to be how much? How much this will be? 840. Or this is x2 is going to be, if I cancel these two, 280. So it's 280 into 4. So that comes out to be 4 into 8, 32, 1120 meter. It should be 1120 meter. Alright? It should be 1120 meter. Okay, so we have solved these two problems, center of mass, BSc